Now let's try to solve one problem on RO based system. Design a single stage RO desalination system, a reverse osmosis based desalination system, by calculating permeate salinity, brine flow rate, and the membrane area. So data given: water permeability 2 meter cube meter square per second, salt permeability given, feed salinity given, this sea water, feed water rate given 2.5 kg per second, permeate flow rate. So I have one pot here. Here I have this one given 42,000 ppm, and my target ppm 145 ppm, and osmotic pressure feed rate to 2.5 kg per second, and permeate flow you are getting permeate, this is 1 kg per second. Feed pressure also given, P given 8000 kPa. Reject pressure is given, 7800 kPa. Permeate pressure is given, permeate pressure 101 kPa permeate pressure. Okay, now we have to calculate different parameters. So first do material balance. Mb equals Mf minus Md. Now Mf is feed mass flow rate. So feed mass flow rate, it is given Mf. Md permeate flow rate, Md, and Xf feed salinity, Xf. Mb 1. Now this is giving now 2.5 minus 1 equals 1.5 kg per second. This is mass flow rate. Now salt balance. This is a brine. This is water material balance. Material balance and salt balance. How much salt was there? How much salt you are separating? Mf, the formula is Mf Xf equals Mb Xb plus Md Xd. Okay, Mf is given 2.5 into Xf. Xf is given 42. So this is 42,000. Actually it is 42 kg per meter cube. Now equals 1.5 MB you already got into XB. XB value I don't know, plus MD value 1 into XD 0.145. this is given XD. Okay, now if we calculate, XB is coming 69.903 kg per meter cube. This is brine salinity. Now okay, I'll put the next page. Now X bar equals average salinity. Average salinity on the feed side. Okay, so X bar average salinity on the feed side. So equals Mf Xf plus Mb Xb divided by Mf plus Xb. This formula you have to remember. So this coming like 2.5 into 42 plus 1.5 into, we just calculated 69.903, and Mf value 2.5 plus Xb value 1.5. So it is coming 52 42.46 kg per meter cube. Now salinity of various stream. So pi f salinity of the stream to calculate osmotic pressure. So pi f equals 75.84. Already told that we can approximate like this. Xf equals 70. So xf value 42. So it is coming 3185.28 kPa. Pi b is coming 75.84 into xb. It is coming 5301.45 kPa. Pi p equals 75.84 into xp equals so 75.84 into 0.145 equals 10.9968. Okay. So average small osmotic pressure. Average osmotic pressure. So pi equals 0.5 pi f plus pi b. So this is giving 0.53185.28 plus 5301.45 equals 4243.366 kPa. And net osmotic pressure del pi net equals pi bar minus pi p equals 4243.366 109968 equals 4232.3 kPa. Now del p 0.5 pf plus pb minus pb equals, it is coming 0.5 8000 minus 7800 minus 101 is giving 7799 kPa. So permeate flux area, md discharge, a kw permeability, del p minus del pi. So 1 equals a 2.05 10 power minus 6 7799 minus 4232. So this is giving a equals 136.76 meter square. So average salinity x bar equals mf xf plus mb xb mf plus mb equals 2.5 into 42 plus 1.5 into 69.903 divided 2.5 plus 1.5. This is giving 52.46 kg per meter cube. So the salt transport ms equals a ks del x minus xp 0.145 into 1 equals a 2.03 10 power minus 5 52.46 minus 0.145. So this is giving a equals 136.5 meter square. So this is your area. Good morning everybody. Today I'll start some problem, then later I'll discuss some other thing also. So already we have discussed that fire fighting system will have one fire hose, then will be nozzle, and you have to direct the nozzle towards fire and it will be extinguished. And for that you need pump also. So pump will be creating very high pressure. That pressurized fluid will be passing through, let's say one pump is here, then high pressure fluid will be passing through this hose or pipe, a soft or pipe, normally it will be there. Then there will be nozzle. So nozzle will be creating a very high velocity jet. Okay, so jet will be directed towards your fire, then fire will be extinguished. So now what will be the nozzle size, what will be the hose size, we should know. Then accordingly we can take action if fire is there. So here one problem you can see, a fire hose uses in a major structural fire has an inside diameter 6.4 centimeter. So hose diameter 6.4 centimeter, and the hose carries water flow rate 40 liter. Q is given 40 liter per second, starting at a gauge pressure 1.6. So P gauge 1.62 into 10 power 6 Newton per meter square. The hose rises 10 meter. So hose actually it will be slanted. Okay, then nozzle is there. So hose rises 10 meter. This is 10 meter along the ladder. Okay, then inside a nozzle inside diameter. So nozzle is be like this. So this nozzle diameter is given 3 centimeter. Okay, then it is going to hose. So this is 6.4. Okay. Acceleration G value also given, so that you will get unique solution. Everyone should get 9.81 meter per second square. Now how to solve this problem? So what is the pressure inside the nozzle? So you have to calculate the pressure here. So pressure will be converted to velocity. Okay, so Q is given 40 liter per second. So 40 liter means 40 divided by 1000 meter cube per second. Okay, so liter into meter conversion is there. Now pressure P1 equals 1.62. Okay, 1.62 into 10 power 6 Newton per meter square. Okay, it is already given. Now you have to apply Bernoulli's equation. Bernoulli's theorem says P1 by rho g plus V1 square by 2g plus H1 equals P2 by rho g plus V2 square by 2g plus H2. So here we are assuming friction losses are not there, other losses are not there, and we are assuming that at initial stage of the pipe the elevation is H1 and at the end elevation is H2. So if we assume at initial stage there is no elevation, so H1 is 0, H2 will be having value 10 meter per 10 meter only. Now V1 equals flow rate divided by area. So flow rate is 40 divided by 1000, already you have seen, and area is pi by 4 d square. D means we have given 6.4 and you have to convert into meter, so 100 square. So it is giving 12.43 meter per second. Now V2 equals, same way we have to calculate. Q, flow rate you are not changing because you are not destroying mass, and we are assuming water is incompressible flow. So flow rate is same. Flow rate like volume flow rate or mass flow rate is same, and area. Let's say first one A1, second one A2. So area is changed. So in that case, formula will be like 40 divided by 1000 divided by pi by 4, 6.4. It is not 6.4. It is 3.3 centimeter. 3 by 100 square. Okay, so this is giving 56.588 meter per second. Now rho density of water is 1000 kg per meter cube. We are assuming H is given already 10 meter, H2 actually, G is given 9.81 meter per second square. So P2 equals P1 minus rho into 0.5 V1 by V2 square by 2, V2 square minus V1 square minus H rho G. So this gives 8.08 into 10 power 3 Newton per meter square. So this is your solution. So whenever you are solving this type of problem, you should look at the units also. Here centimeter, meter, mixed units are there, so I converted into meter and I solved. So whatever unit you use, same unit should use, so that there will be no calculation error or decimal error. Now see the problem problem 3. Next problem: a fire hose nozzle directs a steady state water of velocity 50 meter. Fire hose nozzle is here and velocity is here. Velocity equals 50 meter per second at an angle 45 degree. So this is 45 degree. 45. I'll make horizontal line. This is 45 degree above the horizontal. The stream rises initially. Okay, it will be reaching to maximum height, then again it will be falling down, right? If stream rises initially but then again falls to ground, so definitely assume the water is incompressible and inviscid. Consider density of air and air friction negligible. Assume that acceleration due to gravity 9.81. So all other losses are ignored here. So maximum height in round of 2 decimal places. Okay, maximum height means this one you have to calculate, h max. Okay, now this velocity component will have two values. One will be vy, one will be vx. Okay, so vy will be giving the fluid to maximum height, vx will be maximum reach. G value already given 9.81. So vy equals v1 sine theta. So if it is theta, so vy is v1 sine theta. So 50 into sine 45 degree. So this is giving 50 by root 2 meter per second. And vx, this is v1 or vy, this is vx, v1 cos theta. So it is giving 50 by again root 2, cos theta value root 2, root over meter per second. Now maximum height, (50 by root 2 divided by 2g). Okay, now v at y max. So it velocity at y max, the vertical velocity, will be 0. Now h max will derive like this formula: v o equals vy minus gt. G means acceleration due to gravity, vo means maximum velocity at h max, velocity at h max. Okay, now vy equals gt, because velocity h max equals 0 actually, so vy equals gt. Now t becomes vy by g, so h max equals vy t minus half gt square. You can remember the plus 2 formula: s equals ut plus half ft square. F means friction, acceleration due to gravity or acceleration. So this will become vy square by g minus half g v y square by g square. Okay, because we are putting this value here. Now h max becomes half vy square by g. So then h max becomes 50 square by 2 into 2 into 9.81. 50 square, 50 is having root. Okay, so this is giving 63.71 meter. So this is your solution.